Alright, welcome to the Learning Target number 7 video here. Just so you guys are aware, I don't have page numbers on here, but this is like the second to last page. Remember, we did the last page, the very back, part of it today in class. I think we got to about right here. So we'll do those here in a little bit, those last two, but then you need to flip back a page. Yeah, flip back a page, and then we'll start doing these. So, Learning Target number 7. I can fluently add, subtract, multiply, and divide multi-digit decimals using the standard algorithm for each operation. Now again, don't just think of, I think you guys have gotten a little bit of a bad habit of simply thinking about the word algorithm as being just like doing the algorithm for division. Like that, but that's not what it is, okay? The algorithm, we have algorithms for everything. Like I told you, you could even think of an algorithm for brushing your teeth. You get your toothbrush out, you put toothpaste on it, you brush your teeth, you rinse, you spit, whatever. Okay, that's just an algorithm is just a step-by-step process. So all of these operations here, they all have a different algorithm. I mean, adding's got their own algorithm, subtracting's got their own, multiplying's got their own. It's just a steps to find an answer. Okay? So, most of this better be review. So hopefully it will be on the test, but hopefully this won't take a bunch of time up. We'll be able to just kind of roll through it because it's pretty easy. Now, the first page here, this is all addition or subtraction. So the biggest key with adding or subtracting, please write this, add/subtract. The biggest thing you've got to remember about the algorithm for these two operations is you must, make sure you are writing this, and capitalize must. You must line up your decimal places. Or some teachers might say line up your place values, which I'll write that. But it doesn't matter. It's the same thing. Place values. Okay? So you're not adding the ones place to the tens, the tenths to the hundredths. You can't do that. You have to line up every place value, which that can start then by just simply lining up the decimal place. Okay? So we'll do this one together here. Here I have 0.42. And also, the great thing about addition is it doesn't matter which number is on top or bottom in your addition, because addition is commutative, which means 4 plus 3 is going to give you the same exact answer as 3 plus 4. Okay, so just keep that in mind, that it doesn't really matter which one you put on top or anything like that. Okay, it just matters that you line up your decimal places. You must have that, or line up your place values. Okay, so here I have 0.27. Okay, since that 0 right there is in the ones place, I'm going to leave it under the number that's in the one place there. And the one that's in the tenths, which is the 4 there, I'm going to put the 2 directly under it. And then the 7 is going to go directly under the 2. Okay, so everything's lined up. Everything's all good. You always do this with adding and subtracting. Sorry about that. Okay, so now you just add it just like anything else. You can bring this decimal point straight down, and then everything stays in the place values. Everything stays right lined up. Just to remind everyone, this is the hundredths, which would be the pennies. You're going to hear me say that a lot. This is the dimes or the tenths. This would be the dollar bills, and then you could go further each way on it. Okay, so I always like to think of this as money. So here I have 2 pennies. Add 7 to it. Now I have 9 pennies. 4 dimes plus 2 dimes would give me 6 dimes. And $0 plus $0 would give me $0. So there you go. 0.069. Or you could say it, or how you should say it, 69 hundredths. Okay? Here's this one now. Let's do it. So the first thing I'm going to do is I'm going to line up 0.61 plus, okay? I know that 0 is going to have to go directly under that 0. Put my decimal in there. The 3 is in the tenths, so it's going to be right below the 6. The 2 is going to be in the hundredths, so that's going to go directly above the 1. And then the 9 is actually going to go on the other side here, in the thousandths. So for this case, in this case right here, we're going to add a 0 to the end of 61 hundredths and make it 610 thousandths. Okay, so then we add them. 9. 1 plus 2 is 3. 6 plus 3 is 9. Bring my decimal straight down. 0 and 939 thousandths. Okay. Pause and try this one real quick, please. Okay. Here we have 3.25, and I'm going to add it to 4.6. Notice the ones place gets put with the ones place. The dimes or the tenths gets put with the tenths there. And then I'm going to put a 0 there because, again, that doesn't change the value of it after the last number to the right of the decimal. Then I add it. 5. 2 plus 6 is 8. Bring your decimal straight down, 7.85. So 7 and 85 hundredths. And the last one here, 17.27 plus 3.88. Okay, again, lining up all the place values just like I'm doing here. It's all about lining up decimal, really. I mean, that's really what people say. Okay, 7 plus 8 is 15. So we have 15 pennies, if you want to think about it that way. That's our pennies. We have 15 pennies, so we put 5 of them there. We take the other 10 pennies and we turn them into 1 dime. That's why you carry, as I've said, and I know you guys get annoyed whenever I do it, but I'm going to continue to do it. Okay, now I have 1 more dime here because I cashed in 10 pennies. So I have 1 dime plus 2 dimes is 3 plus 8. Now I have 11 dimes, so I have 11 dimes. Okay, so I have 11 dimes. I can't put a double-digit number in one place value, so I take one of those dimes and put it down there. So now I have 10 total, and I'm going to turn those 10 dimes into one $1 bill. Okay, bring my decimal down. One $1 bill plus 7 would be 8, plus 3 would be 11. Again, now I have 11 $1 bills. I bring 1 down. I turn 10 $1 bills into one $100 or one $10 bill. Now I have 2 $10 bills. Okay, 21, 15. Let's go down and do subtraction now. These are going to work the same way. Now, make a note to yourself. Subtraction, order absolutely matters. As I stated up here, addition is commutative, which means you can flip the order of any addition problem and you're going to get the exact same sum. Okay? Down here, you cannot. You got to keep this as the first number. It's this, and you're taking away this from this. Okay? You got to keep it in that order. So that means when you're stacking them up, you got to put the first number on top, and then you line up your place values just as you always have. Okay? All right? Now here again, this is my pennies, this is my dimes, this is my $1 bills. Okay? I'm trying to take 5 pennies from 1 penny. Is that going to be possible? No, it is not. So I'm going to go over and I'm going to take one of these dimes I have. I take a dime. Okay, now I have only 8 dimes there. So I took 1 dime and I'm going to convert it into 10 pennies. So I have 10, so let me write this. 1 dime is becoming 10 pennies. And I already had 1, so now I got 11 pennies. Okay, that's why we borrow. We're actually borrowing a dime if you think about it that way. Okay, then I got 11 pennies. Take away 5 of them, I have 6 of them. 8 dimes minus 4 dimes is going to give me 4 dimes. Bring my decimal straight down, and then obviously 0 minus 0 is 0. Okay, same thing here. 4.7 minus 0.83. Okay, so again, we got to put a 0 in there. Remember, 4.7 is the exact same thing as 4.70. And if you think about it in terms of money, $4. If you have 4 $1 bills and 7 dimes, don't you have $4.70? I hope you're saying absolutely. Okay, so I obviously don't have any pennies. I had to add the 0 on there, so I don't have any pennies. So I've got to go over here and I got to borrow a dime again, just like we did on the last question. I have 6 dimes now. I turn that 1 dime into 10 pennies. Now I'm ready to subtract. I now have 7 pennies. I'm trying to take 8 dimes from 6 dimes. Oh, okay, so now we got to borrow again. So what are we borrowing? Well, we're borrowing a $1 bill. So we have $1 as a bill. So we take it to the bank. We are now going to take that $1 bill when we get to the bank. Let me erase that so I can see. We're going to take that $1 bill that I had there, and I'm going to turn it into 10 dimes. So now I've got 10 dimes, so that means I've got 16 total dimes. 6 plus 10 is 16. 16 minus 8 is 8. bring your decimal straight down. 3 minus 0 is 3. So you have $4.70 minus 83 cents. We have $3.87. That's, yes. Okay. Try this one on your own, and then we'll move on. Okay. Hopefully you've already done it. You better have already done it. Okay. Minus 9.49 again. Setting up your decimal places. Okay. We don't have enough pennies to subtract, so we got to go borrow a dime. Okay. We take that dime and turn it into 10 pennies. So now we got a total of 17 pennies. 17 minus 9 is going to give us 8. Uh-oh. We don't have any dimes, so we got to go over and borrow a $1 bill and turn it into 10 dimes. 10 dimes equals $1, right? 10 minus 4 is going to give us 6. Bring our decimal straight down. Now, we're trying to take $9 from 1. We don't have enough. So we go over and take our only $10 bill we have, and we make that into 10 $1 bills, which gives us $2.68. Hopefully you got that or something near that. Okay, let's go on to the next page. Hang on, it's right there. Okay, here we go. So it's not the last page, but the next to last page. So here we go. When you're multiplying, as we've seen on review sheets, we do not line up the decimal places. For instance, we have 2.8 times 0.3. We don't line them up and do this and put the decimal there and do that. We don't do that. Even though it works out on this one, that's not how we do it. Okay? We do 2.8 times 3, or 0.3. We just shove whatever the second number is, we shove it all the way to the right and work our way that way. And then I told you, I want you to always just take out the decimals. Do 28 times 3. That would be 84. And then you go up and say, I had 2 numbers to the right of the decimal, so I've got to move my decimal 2 places. That's why it's 0.84. Okay, let's go down and practice on some of these. So these are already set up for you here. 9 times 7 is 63. Carry your 6. 9 times 0 is 0. Plus 6 would be 6. And then 9 times 0 would be 0. So we know right now, let me zoom in a little bit on this problem. We know that what we really just did is we did 7 times 9. And that's essentially what we did, right? Because remember, we just take out the decimals. And if you just take them out, isn't that basically what we're doing? Okay. So then you get 63, and then you go back to your problem and you say, well, then how many decimals did I have? Well, I had 1 number to the right of the decimal, and I had a second number. So my decimal is going to go 1, 2 to become 0.63. Let's go down to number 6 and 7 down here. So here we go. This is going to be 3.46, but we're just going to go ahead and make it 346 times, and we're just going to make that 4. Notice how I shoved 4. Since it's the furthest number to the right, I shoved it all the way to the right. And we're just going to do that. We're not even going to worry about these decimals. We're not even going to worry about it. We just get rid of it. There it is. Get rid of it. Get rid of your decimal. That's what we're doing. Okay? Now, 6 times 4 is 24. Now we're going to carry our 2. 4 times 4 is 16, plus 2 would be 18. Carry 1. 4 times 3 is 12, plus 1 would be 13. Okay? Now, we know that the answer to 346 times 4 is definitely 1,384, right? But keep in mind, we've now got to go back and put our decimal in. Now, since this is a whole number, our decimal is right there. Every whole number has a decimal after the last number. So we've got to go up and we got to see how many numbers did I have to the right of the decimal. I have 1, 2, 3. So since I have 3 numbers to the right of the decimal, I'm going to move this 1, 2, 3 to become 1 and 384 thousandths. Okay? I would like you guys to all try number 7. Something get cut off there. Actually, let's change this a bit. Let's make it that. Hopefully you didn't already pause. But try to do this one then. Okay, hopefully you've done it. So we have 23.6 times 4.34. Notice no decimals are lined up there. I took the number that was furthest to the right and shoved it to the number that's furthest to the right in that one. Okay, and then just worked off of that. Okay, now keep in mind, I'm going to get these decimals out of here. I'm not even going to bother with them. Okay, 6 times 4 is 24, carry 2. 4 times 3 is 12, plus 2 is 14, carry 1. 4 times 2 is 8, plus 1 is 9. Okay, now we need to always go up and get rid of our carries. And also we need to get rid of that. Now, since we're on the next number here, we've got to put one placeholder to account for that one we x'd out. 3 times 6 is 18, carry 1. 3 times 3 is 9, plus 1 is 10, bring a 0 down, carry 1. 3 times 2 is 6, plus 1 would be 7. Okay? Now again, get rid of your carries and get rid of the place value you just took care of. Okay? Now, since I have 2 x'd out, I'm going to put 2 placeholders in there. All right? Now, 4 times 6 is 24, carry 2. 4 times 3, right here, would be 12, plus 2 is 14, carry 1. 4 times 2 is 8, plus 1 would be 9. Now, you've heard me say it on review sheets a long time. We've done so many of these on review sheets, and you've heard it all year long. I don't have the neatest handwriting in the world, but the one thing you can definitely see is how I got all my place values lined up. 4 plus 0 is 4. 4 plus 8 is 12, carry 1. It's going to become 14, carry 1. 1 plus 7 is 8, plus 4 is 12, carry 1, and we have 10. Now, we do know that the answer to 236, wow, blasted. We know that the answer to 236 times 434, that is definitely 102,424. Okay, the whole number. But that's not the answer to the question. We now got to go up and we got to count up how many numbers to the right of the decimal we had. So we have 1, 2, 3 numbers. So the correct answer is 102 and 424 thousandths. Okay? Let's go to the next page. All right, guys. We're going to do a couple of these long division. Try to keep it short here, shorter. Do a couple of these. Okay. Now, we have to know which one our dividend and which one our divisor is, which I think we're all finally starting to get. Finally. You have to. If you're not, you're still not where you need to be. You need to know this. We know that this division problem right here can be written like this because all fractions are division problems. So that means that all division problems can also be written as fractions. It works the same way. Okay? Now, when you're doing long division, and this goes right with what we did up here, and everybody please write this somewhere. I know you probably don't have a lot of space, but write it. The divisor must, capital M-U-S-T again, become a whole number. Okay? Must become a whole number. Must become a whole number. You cannot do long division without making that become a whole number. Okay? Now when I say make it become a whole number, there's a lot of ways you can do it. I mean, you could technically, don't write this. You could technically take this and multiply it by 2 and get 7. And then multiply this by 2 and get a number. But they're not always going to work that way, especially like this. I mean, I don't know what that times anything is going to give me a whole number. So that's the whole point, is to make it whole by making equivalent fractions. So what we're going to do, rather than trying to figure out what we could multiply by, we're just going to simply move the decimal. So we're going to take that decimal, we're going to say, I'm going to move you to there. So we're basically making that new divisor, we're making it 35. Now, I'm going to remind you real quick. We went over this yesterday. Whenever you're multiplying by 10, or multiplying by 100, or multiplying by 1,000, or multiplying by 10,000, whenever you're doing those things, you really don't need a calculator to do these. Okay? I'll do a couple of examples. Okay? You don't need a calculator to do these. Okay? I can do these all mentally. And how you do it, since you're multiplying by a whole number greater than 1, we know that this number is going to get larger, right? When we multiply by a whole number greater than 1, it gets larger. So when I'm doing this here, I always can just look and say, okay, I got 1 0 there. Since I have 1 0, sorry about that. Since I have 1 0, my decimal is going to just move one place to become 8.7. Okay? 0.9 times 100, there are 2 zeros. So that means my decimal is going to go 1, 2. Let me write this over on this side. So it's 0.9 right now. And what I'm going to do is I'm going to say 2 zeros, so there's 1 0, and there's another 0. Since it's like that, I got to add a 0 in there. So that means that 0.9 times 100 is 90. Okay? 0.915 times 1,000. Okay, so here's 0.915. There are 1, 2, 3 zeros, so I know I got to move my decimal 3 times to the right. 1, 2, 3. So that's going to be 915. Okay, here 0.821. It's going to move 1, 2, 3, 4 times. 1, 2, 3, 4 times. We got to add a 0 in there. So that means 0.821 times 10,000 is 8,210. Okay? I hope you all understand that. It's just all about counting the zeros. Dividing by 10 or dividing by 100 or dividing by 1,000, dividing by 10,000 is the same thing, except for when you're dividing by those, the decimal goes to the left. Okay? For instance, if I did 0.91, let me do a different one. Let's do 9.1 divided by 10. I don't have to pull out a calculator. I just take my decimal and move it this way 1. 0.91. Okay? So, going back down to here, why did I show you that? Well, this is what we're doing. When you're making the divisor a whole number, like you have to do before you start, if you move the decimal just one time, you're multiplying by 10. So, as we know, since this is a fraction, and we can never, if we have a half of a pizza, and we take that denominator and we change it to 8, remember, whatever we do to the bottom, we must do to the top. That's why 4/8 and 1/2 are equivalent. That's why 4/8 simplifies to 1/2. They're equivalent. The same thing is happening to the top and the bottom. Well, this is no different. If you multiplied by 10 to the bottom, you must multiply by 10 to the top. Okay, so that's going to become 385. Again, because 1 0, the decimal moves 1 to the right. Now, I just want to make this clear. You do not have to show this every time. That's ridiculous. That's just why you do it. Okay, and I will probably ask you to explain why. The key for you all to remember is if the divisor's got one decimal place that it has to move, then you've got to move your dividend one place. Okay, so now what the problem you're actually going to do is 385 divided by 35. You have the same exact equivalent fraction because you moved the decimal one time to both the dividend and divisor. Another way to say it, you multiplied by 10 to both the dividend and divisor. Now, 35 goes into 38 one whole time. We multiply around, get 35. We're going to subtract. Remember the check step. Remember this. Does McDonald's sell cheeseburgers? Okay, we've multiplied, we've subtracted. Remember this step right here. We just make sure that this difference, after we subtract, is smaller than our divisor. And it is. Okay, so now we're ready to bring down. So I bring down my 5. 35 into 35, one whole time. 35 times 1, obviously going to be 35, and we get 0. So the answer is 11. You don't put decimals back in. You don't do anything. The decimal is right here now, so that means it's right there. But the whole number 11, we know has a decimal there. Let's do the next one. First thing you identify is the divisor. And you say, okay, before I can even start the algorithm for long division, I've got to take this decimal and go boom, boom, 2 places. So by doing that, what am I multiplying by? Well, I'm multiplying by 2, or I'm sorry, by 100, right? So if I multiply the divisor by 100, what do I have to do to the dividend? They move that one twice also, okay? Let me show you the mistake. This is the mistake that students make, and this will be the last one, I promise. The mistake, this is what they do. Students write this out, and they go, oh, here, they say 8.324, because that goes inside the house, divided by 0.02. They write it just like this, and then they go, okay, both numbers need to become whole numbers. 1, 2, and they move the decimal. That's how they do it. But think about it. You're making a totally different fraction. I can't say, okay, if I have half of a pizza and I take that half and I'm going to cut the whole thing into 16 pieces, which is multiplying by 8, I can't say, oh, now I got 4/16. That doesn't make any sense. They're not equal. They're not the same. Well, that's what you're doing, because on this one, you're multiplying by 1,000. 1, 2, 3. This one, you're multiplying by 100. You're creating a whole new problem. Okay? So, remember, when you line it up, and you're more than welcome to write it in just like this. Some people leave the decimals in, and then they go 1, 2, move it there, and then they go 1, 2, move it there, and then directly up. Okay, that's the whole point, is just to figure out where it's going to be there. 2 places there, 2 places there, straight up. That's how you do it. And then from here, it's easy. 2 goes into 8. Uh-oh, my board's freezing. Hang on. Okay, whoops, whoa. Okay, 2 goes into 8 4 times. Notice how I put the 4 directly above the 8. Then I multiply. Subtracting it 0, make sure it's smaller, it is. Bring down my 3. 2 goes into 3 2 times. 2 times, what am I talking about? 1 time. 1 times 2 is 2. Subtracting it 1. Now I'm ready to bring down my next 2. 2 goes into 12. 6 times. Notice how my 6 is above those 2's. That's going to be 12. Subtract and get 0. Bring down our 4. 2 goes into 4. 2 times. 2 times 2 is definitely 4, and we get 0. And there's my answer. Okay? But it all started because I knew that since that had to be moved 2 places, I had to multiply it by 100. So if I multiply that part of the fraction, remember, like this, if I multiply this by 100, then I've got to do the same thing here. Very important to make it 324 or 832.4. Okay? Kind of tricky, but not difficult. It's just that it's the same process as we did today in class, and you guys seem to do well with it. The only difference is we've got to do this wherever I wrote it here. The divisor here and here has to become a whole number. Okay? All right, guys. See you tomorrow.